Welcome to the third part of Lecture 2, Operations Strategy. We have discussed the reason for strategy and the content for strategy, and in this last part, we will discuss operations strategy and productivity. Now that we have discussed what strategy is, let us narrow the concept into operations strategy. Operations strategy is a functional strategy, meaning that it is under the umbrella of corporate strategy. For example, Apple pursues differentiation strategy as a company and focuses on increasing quality of the products. As a result, the operations strategy should be aligned with the corporate strategy and find a way to set the product to be apart from the other products. MacBook Pro uses aluminum rather than plastic in the body, and the company came up with different ways to interact with the computer. When the majority of the computers were using mouse, MacBook Pro adopted touchpad that recognizes finger moves. In this case, we see that Apple's corporate strategy is aligned with its Apple's functional strategy is aligned with its corporate strategy. This strategy is reflected in the mission statement, and this mission statement drives various components of the company to deploy various tactics to achieve the goals. So as you can see in this triangle, the mission drives down everything to the tactical levels. We defined strategy as organizational plan, action, and policies that create advantage over competitors. Corporate strategy defines business strategy. Business strategy again dictates what operation strategy go after. When a consistent pattern of decisions is formulated, a tangible result will arise from the decisions. Lastly, there is constant feedback of internal and external analysis to understand any changes happening in the industry and the organization that lead to strategic fit adjustment. Business strategy defines how a particular company will compete, such as in customers' intimacy, product leadership, and operational excellence. In this operational strategy is significantly influenced by the corporate strategy, but it also provides the corporation with the timely feedback. Here is an example of two different operation strategies. Look at Shop 1. It's using a broad contribution, a limited, low price, and wide consumer advertising, decentralized storage, readily available merchandise, rock bottom cost, large lot size, low and medium skilled workers, and large scale plants. What kind of strategy is this shop utilizing? It's cost strategy. And to fulfill the cost strategy, operations is tailored around the strategy. Walmart or IKEA would fit this example. Look at the right-hand side, which details the operations practice of Shop 2. High price, high style, company with exclusive distribution channels, many model and many style changes, production to order, extremely reliable high quality, small lot sizes, high skilled supervisors and technicians, flexible toolings. This company is implementing quality strategy. Raymore Flanagan or La-Z-Boy would be a good real-life companies that feature these characteristics. The point in this case is that according to the strategy, operations has to be modified. If you observe the real world with this lens in mind, you will find many other examples that are aligned with their operations. Now, on the topic of evaluation of value, let me remind you that operations management is a transformative process of inputs into output that creates value. We have learned that companies may set out to accomplish different goals and strategies. All in all, strategy can make or break a company because it empowers a company to surmount limitations and resource constraints. As discussed in the first lecture, we do need to define what the value is. Here is a popular measure of value measures, which is productivity. Productivity is well known as the output over input. In other words, how many things are produced per hour, a day, or labor, or a period of time. It could be quarters. For example, when 1,000 units of air conditioners were produced for 250 labor hours, the productivity is 4 units per labor. When an operations manager has this productivity number, he or she can use it as a basis of comparison and improvement. Say a healthcare clinic was able to process 1,000 COVID-19 patients for 25 people working for 10 hours, which produces in total 250 labor hours. Its productivity is 1,000 divided by 250, which is 4 persons per labor hour. Next day, the facility could analyze its processes and improve its operations and layouts to process more people because you have this measure of productivity to compare. Productivity is not as simple as we think because multiple factors go into the equations. We not only have labor hours, but also materials, parts, equipment, and operations methods. How do we put them into the same equation and compare them all, right? One way is to use multi-factor productivity. Various productivities, such as labor, capital, energy, and other factors are calculated and compared together. It's imperfect measure, but acceptable way to gauge the productivity. The goal is to increase the output while maintaining or decreasing the input. So we see labor productivity or capital productivity, energy productivity, we put them together as a multi-factor productivity. Now, let us take a look at an example here. Let me read this example for you. Glassboro Glass Company has 10 staffs, each working 8 hours per day. Payroll costs $100 and overhead cost is $50 per day. This company makes 10 audio sets each day. This company is trying to buy a new machine that allows the processing of 15 audio sets per day. For using this machine, all things are some except for overhead expenses, $100 per day. The first question is compare the labor productivity before and after the new system. And the second question is comparing the multi-factor productivity before and after new system. So let's calculate this together using productivity. If we summarize the information, the number of steps are 10, and each working 8 hours, and for payroll costs of $100 per day, and overhead expenses of $50 per day, output 10 units per day. New system, if we buy and implement that equipment, we are going to be able to produce 15 more units, and overhead cost will be about $100 per day. Given this fact, how can we calculate the labor productivity? So labor productivity with the old system will be 10 units per day and 80 labor hour per day because 8 hours and 10 people working every day. and that's 10 divided by 80 labor hours, which gives 0.125 units. So that's the productivity with the old system. Now, if we calculate the productivity with the new system, we learned that it produces 15 units per day, and overhead costs, or the number of people who are working, is the same because we did not change labor productivity. What we did was we adopted a new system, right? So it has nothing to do with labor units. So we used the same number of people, 80 people were working. I'm sorry, 10 people were working 8 hours per day. So 80 labor hours per day. So if you do that, 15 divided by 80, then it will give you 0.1875. So we see that labor productivity increased, but we are not so sure if it's the direct result of labor productivity, whether it might be because the machine did more work. But anyway, we see that from these numbers, the new system improved labor productivity. The question is, how much is it? How much did it increase the labor productivity? That we can calculate too. But let us first calculate multi-factor productivity with all the system. We know that the output was 10 units per day with the old system, and we also know that the overhead cost was $100 per day for the payroll, plus the overhead expenses was $50. So $100 plus 50 is 150. Therefore, 10 divided by 150 yields to 0.067 units per dollar, right? So that's one multi-factor productivity. And another thing that we can do is with a new system, which has 15 units, and we know that the labor cost stays the same, $100, and the expenses, overhead expenses, increased to $100 per day. So it increased to 100. So 15 divided by 200 will give you 0.075 units per dollar. So we see that it increased a little bit from the old system, 0.067 to 0.075. So there was a slight increase, but how much increase is it? We have to calculate that. So now let's calculate the improvement for labor productivity, and that is the improved productivity, 0.1875, minus the previous productivity, labor productivity, 0.125. You subtract that and divide it by the original productivity, 0.125, and it produces 0.05. So therefore, we can say 50% of increase in labor productivity happened as a result of this new system. Similarly, we can do improvement for multi-factor productivity. So the initial productivity with all the system was 0.067. So we can subtract that from the improved multi-factor productivity, 0.075. So 0.075 minus 0.067 gives you 0.119. So therefore, we can say 11.9% of multi-factor productivity increased in this new system. So here's an example of that. So multi-factor productivity can become quite complicated. Let me talk about now problems of measuring productivity. The first problem is quality. How to measure the improvement of quality with the productivity. For example, the same car, but its design was simplified and engine efficiency improved each year or each month. And that quality improvement may not be reflected in the productivity measure. The second problem is external elements may influence on the productivity. In other words, such external elements as oil price increase would strike the economy hard. Although people work the same number of hours, the productivity will decrease due to the increasement in the gas price. Or say, people are working, however, the suppliers were not delivering their products or parts to the factory in a timely manner, then although they have the same labor productivity, they cannot work because of the shortage of the parts, which happened in COVID-19 situation or many other disruptions. The third problem is precise unit of measure may be lacking. When it comes to knowledge work, it is difficult to define the units of measure. It may not be a matter of writing a report, but the quality of the recommendations to the clients or the problems. So in this knowledge work or other intangible work, it's quite difficult to measure the units of productivity. So please remember that productivity measure is not a perfect one. So let's summarize what we have learned so far. In summary, we have learned what strategy is. Strategy is the impetus to overcome limitations and resource constraints and competitions. So that's why it's so important. What is strategy? Strategy was defined as an organizational plan, action, and policies that create sustainable advantages over competitors. And we learned characteristics of sustainable advantages. It has to be inimitable, valuable, and non-substitutable. When a company's advantage has that characteristics, it's sustainable. Lastly, we talked about operations strategy and productivity. Operations strategy is it needs to be aligned with corporate strategy and follow that direction and create creative tactics that can support corporate strategy. And therefore, alignment is such an important issue in operations strategy. And we also learned that productivity is the primary measure to gauge values that operations activities creates. Thank you for watching this video lectures, and I hope now after watching these lectures you are convinced that operations strategy is capable of creating competitive edges for the companies. Thank you.